So here's a histogram type question. I've got to complete the table and I've got to complete the diagram from the information that's given. So first of all, I have to remind you of the principles of the histogram. The area must be proportional to the frequency. Now, each bar is made up of an interval width times what we call the standardized frequency, not the frequency, the standardized frequency. And it is that's either proportional, or in this case we'll let it equal the frequency. So if we look, we've got all the intervals here, so we can put the interval widths in. We're on a continuous scale, we're going up to 10, and then across to 10 and so on, so it's fairly straightforward to work out these widths. Occasionally it can be more difficult if these numbers are the endpoints of a continuous scale that don't meet, but that's not the case here, and it usually isn't in GCSE. I tend to bring that in at AS level. So we've got the frequency here of 5. Coming back to my formula here, if we know the interval width, we can get the standardized frequency by doing the frequency divided by the interval width. So the frequency of 5 divided by the interval width of 10 gives me a standardized frequency of 0.5. And we can actually see that this has already been put in for us, so we know that's all fits. Now the second bit hasn't been drawn, so we've got to do that. We know that the standardized frequency has not been given, and we haven't been given the frequency, so we'll need one of them. So I'm going to give you the frequency of 20. Now if we have the frequency of 20 and we divide it by the interval width, then that will come to 1. And so we simply go to our histogram and draw in from 1. Okay, so now we go to the third piece of information. Now with this one we've got the interval width of 20, and again I need to tell you, this has been actually drawn in, hasn't it? So we've got the standardized frequency here of 1.5, so if I put that 1.5 there, then working this way, the standardized frequency times the interval width will give me the frequency. So I can fill this part of the table in. 1.5 times 20 gives me a frequency of 30. The next part of the table, we've got the frequency and we've got the interval width. So if I do 8 divided by 20, that's the same, so I'll put that 8 divided by 20, it's the same as 4 divided by 10, it's 0.4. I can mark that in at 0.4. So I'm going from 50 to 70, there's 0.5, so just come down a fraction, mark it there, just go there and then drop it down. In the exam you'd have a gridded graph paper to count up 4 units to get to your 70. So that bit is done. And then finally the last bit, again we've got the standardized frequency, we've got the interval width, standardized frequency times the interval width. In this particular diagram is giving me the frequency. 0.2 times 30 is 6. And so we have the table complete. We can then finish off the diagram. So my interval width of 30, my standardized frequency of 0.2, and then a question is complete. So I've shown you how to draw the bars. You need the standardized frequency and the interval width. From the information you were given, we could either take the standardized frequency and the interval width and calculate frequencies that were missing, or we could take the frequency and divide it by the interval width and then get the standardized frequency, enabling us to finish the histogram. And that's how a histogram works. The one thing to add is that it can be in some cases that this is multiplied by some scalar. And in this particular case, I've shown you I kept the k as 1. So the standard frequency times the interval width gave me the frequency. Suppose that it was standard frequency times the interval width was double half the frequency, and then as long as I applied a doubling to the others, then it's better to show you an example of this in a later histogram. You need to check that it does fit with your diagram. So what we had was the 0.5 times the 10 giving us the 5. So we knew from the start that if we multiplied that times that, we got our frequency. Had it come to 2.5, for example, and the frequency was 5, we'd have then had to apply the scalar of 2 to go up to the 5. And that can occasionally happen, but I hope that doesn't put you off, and I hope you can see clearly how this one worked.